In this video, we'll be learning about proper subsets of a finite set. So for this first problem, we have set M is the set of snacks available in a vending machine. So we have set M has the elements chips, chocolate, and granola bars. List all the proper subsets of set M. So a proper subset is going to be a piece of the set that we're talking about, or just a piece of a set in general. So for example, if we have set A and it has the elements 1, 2, and 3, we'll say B is a proper subset of set A, which just means it's a piece of set A. We can pick any number that's in this set. So we can do a 1, we can do 1 by itself, we can do 2, but we can't do the exact same set. We can't do 1, 2, and 3 because that's not what a proper subset is. A proper subset is just a piece of a set, not the same exact entire set of the original one. So set B can also be, or just a proper subset of set A can just be a single number. So we can do 1, 3, 2, and so on. But also something to note is the empty set will always be a part of any set. It will always be a proper subset of any set. So if we want to know how many proper subsets of set M we have, you have to follow this formula. 2 to the n minus 1. And n is going to represent your number of elements. So in set M we have 1, 2, 3 elements, so it's 2 to the third power minus 1, which 2 to the third power is 8. And it's 8 minus 1, which is going to give you 7. So there's 7 different proper subsets that we need to have. And the reason why we subtract 1 from 2 to the n. So 2 to the n is going to give us how many different combinations we can have in our proper subsets, or our subsets in general. And then we subtract 1 because we're going to get 8 different combinations from set M, but we need to subtract 1 because one of the different combinations is going to be the same exact set, which, remember, a proper subset is a piece of the set, not the exact set. So we have set M, so let's start off with our first combination. So since we're starting at 3, we need to have 2 elements in our first combination. So all these sets I'm going to label as set N. All these are going to be proper subsets. So N, we're going to do the first combination. We're going to say it's going to be chips and chocolate in the first one. In the second one, we're going to swap out chocolate for granola bars. So you have chips and then granola bars. So next, we need to do the other combination. We need to have chocolate and granola bars in the same set. So we have N, and we have chocolate, so that's 3 we have. So next we have to do the single element in our set. So it's going to be N, and then we have chip, and then we have N, and then we're going to do chocolate. Kind of running out of room here. And then we have granola bar. So then that's going to knock us down to 1, 2, 3, 4, 5, and 6. So remember, we have to have 7. So the last combination we can have is the empty set, which means 0 elements. So you can write it as n is equal to, and then have just closed brackets, or you can say n is equal to the null notation, which just means the empty set. So these are going to be your answers. And then we'll include a dotted line if you wanted to use a null notation. But that's going to be your answer. So for the second problem, it says set T is a set of possible outcomes when you roll a die, where you only consider rolling a 1 or a 2. So we have set T has the elements 1 or 2. List all the proper subsets of set T. So remember, we follow that formula. 2 to the n minus 1 and n is going to be the number of elements in your set. So here we have two elements, 1 and 2. So it's going to be 2 to the second power minus 1. So 2 to the second power is 2 times 2, which is going to give you 4, and then minus 1. So we're going to get 3 different proper subsets of set T. So I'm going to label these subsets as set U. And the first one we can do is we have to go down one element. So essentially we start off with one element because originally we had 2, so we just bumped down to 1. So we can say that one of these elements can be 1, the second one can be 2, and the third one, which don't forget, is the empty set. So that's going to be the third one, and we have 3 different proper subsets of set T, so that's going to be your answer. So for this third problem, it says set F is the set of fruit types available in a fruit basket. So we have set F has the elements apple, banana, and oranges. List all the proper subsets of set F. So we follow the formula, 2 to the n minus 1, and we have 3 elements in our set, so it's 2 to the third power minus 1. 2 to the third power is going to give you 8, and then minus 1, so it's 7. So 7 different proper subsets of F, set F, that we need to write out. So I'm going to say G is going to be a proper subset of set F. So we have 3 elements, so we need to get bumped down to 2. So we're going to start with 2 elements for each proper subset. So we're going to have apple and bananas. Did I spell bananas wrong? I don't think I did. And then we have set G, which we're going to do apple, and then we're going to replace banana with oranges. And then the next combination is going to be G, and then we're going to do these two, banana and oranges. So banana and an orange. And then now we have our 3 elements, our 3 different combinations. And now we're going to bump down to 1 and then do a single element in each proper subset. So we have G, so we have apple, and then we have banana, and then we have G, and then we have orange. So at the moment we have 6, and don't forget about the proper subset. Proper subset is an empty set as well. So we have G is equal to, and then we just close our braces, or you can do the null notation, either one works. And that's going to be your answer. Sorry, this is number 7. And that's going to be your answer. So for this fourth problem, it says set C is the set of primary colors used in painting. So we have set C has the elements red and blue, and it says to list all the proper subsets of set C. So we follow that formula again. We have 2 elements in our set, so it's 2 to the second power minus 1, which 2 to the second power is 4 minus 1, and that's going to give us 3. So we need to have 3 different proper subsets of set C. So I'm going to say D is going to be a proper subset of set C. And then we have 2 elements starting off, so we need to get bumped down to 1 element in our proper subset. So we can have red in set D, and then that looks like R. And then the other combination is going to be blue. And then lastly, we have our empty set. So we can say D is equal to, and then just have our empty set. So that's 3 different proper subsets of set C, and that's going to be your answer. So for this fifth problem, it says set P is a set of ingredients for making a pizza. So we have set P has the elements cheese, tomato sauce, pepperoni, and mushrooms. List all the proper subsets of set P. So we follow that formula, 2 to the n, which in this case we have 4 different elements. So it's 2 to the 4th power minus 1. 2 to the 4th power is going to give you 16. It's 2 times 2 times 2 times 2. And then minus 1. So it's 16 minus 1, which is going to give you 15. So this is going to be a lot of different proper subsets. So I'm going to say Q is going to be a proper subset of set P. So since we started off with 4, we need to bump our proper subsets down when we start to 3. So let's do that. So we'll say cheese, tomato sauce, and pepperoni are going to be our first combination. Next, we're going to swap out pepperoni with mushrooms. And then we're going to do mushrooms. And then we're going to do our next combination, but this time we're not going to include tomato sauce. And we're going to use pepperoni and mushrooms. So we're going to still have cheese in it, but we're going to say, instead of tomato sauce, we're going to swap it with pepperonis and mushroom. So we have pepperoni and mushrooms. Now, lastly, we need to do another combination. And instead, we need to not use cheese. So we're going to say tomato sauce. We're going to say pepperoni. And then mushrooms. So since I'm not going to be able to fit this all on one page, I'm just going to put tally marks. So we had 4 for our combination of 3 elements in the proper subset. So now we're going to get bumped down to 2. So we're going to start off with cheese and tomato sauce. And then we're going to say cheese. And then we're going to move to the next one, pepperoni. And then we're going to say cheese. And then mushrooms. Now next we're going to get rid of cheese and we're not going to include it anymore. And then this time we're going to start off with tomato sauce. So we have tomato sauce. And then we're going to move the pepperoni. We're not going to use cheese since we used all those combinations there. So I've added, oh wait. So we did 4 more, so I'm going to add 4 more tally marks. So we're currently at 8 right now. So we're still at tomato sauce, so we have Q is equal to, we have tomato sauce. And then we're going to do mushrooms. Oops, forgot to ask. And then now we're not going to use tomato sauce at all. So we're not going to use tomato and cheese. So the only possible combination left is just pepperoni and mushrooms. And then we close our set. So we have 2 more. So that'll leave us at 10. So now that we used all our combinations for 2 elements in the set, now we can move down to 1. So we have set Q, and then all we got to do is just list each proper subset that just has 1 element from the original set. So we have Q is equal to cheese, Q is equal to pepperoni, Q is equal to tomato sauce, and then Q is equal to mushrooms. So that's 4 more, which if we add 4 more tally marks, we're at 14. Remember, this is 5, 5, and 4. 5 plus 5 is 10, and then we have the 4, so 10 plus 4 is 14. So the last proper subset of this set is the empty set. So we have set Q is equal to the empty set. And then that's going to be our last set, which that would put us at 15. So that's going to be your answer. So for the sixth problem, it says set n is the set of a single digit number. And we have set n, which is equal to 5. Lists all the proper subsets of set n. So remember, we use that formula, which is 2 to the n, which is the number of elements in our set. Now, our element, or element, depending on the situation, is a number. So we don't do 2 to the 5. We do 2 to the 1, because essentially this is just one element in our set. So it's 2 to the first power minus 1. So 2 to the first power is just 2. So it's 2 minus 1, which is going to equal 1. So there's only one proper subset of set n. So I'm going to label O as going to be a proper subset of set n, which we start at one element in set n, so we have to bump it down 1 for our combinations, which 1 minus 1 would give us 0. So the only proper subset of set n is going to be the empty set. So that's going to be your answer.